Welcome to the DIY Honda Garage channel. DTC P2184 indicates a low voltage error in the Engine Coolant Temperature ECT Sensor 2 circuit of the 2023 Plus Honda Accord. The ECT sensor is essential for determining the engine coolant temperature, which the Powertrain Control Module, PCM, uses for optimal engine management. If the sensor output voltage drops below a designated threshold, it signifies a malfunction, prompting the PCM to store this diagnostic trouble code, DTC. The ECT Sensor 2 is typically located in the engine bay, connected directly to the engine block or the coolant passages. It plays a vital role in controlling engine performance and emissions by providing accurate temperature readings. The PCM and ECT sensor are interconnected via wires that relay voltage signals. Thus, any disruption can trigger this DTC. Understanding and resolving this error is crucial for maintaining vehicle efficiency and preventing further damage. The DTC P2184 represents a low voltage condition detected in the Engine Coolant Temperature ECT Sensor 2 circuit. The ECT Sensor 2, situated in the engine bay, plays an important role by measuring the temperature of the engine coolant. This measurement is crucial for the Powertrain Control Module, PCM, as it adjusts fuel delivery and ignition timing based on the engine's thermal state. If the sensor outputs a voltage lower than 0.08 volts, the PCM interprets this as an irregularity and triggers the DTC. The sensor is connected to the vehicle's wiring harness and can be affected by faulty connections, short circuits, or issues within the PCM itself. Therefore, diagnosing this issue involves checking the ECT sensor, the wiring to it, and the PCM's functionality. Several potential causes may lead to the activation of DTC P2184. First, a faulty ECT sensor 2 itself can fail, leading to incorrect voltage readings that trigger the code. Secondly, there could be wiring issues, such as frayed wires, exposed contacts, or shorts that could affect the voltage signal sent to the Powertrain Control Module, PCM. If the wiring appears intact, the PCM may also malfunction, which can cause it to misinterpret the readings from the ECT sensor. Proper troubleshooting involves checking each of these components systematically to isolate the issue effectively. Ignoring this DTC may lead to inefficient engine performance and elevated emissions. Symptoms related to DTC P2184 can include a range of performance and operational issues within the vehicle. One of the most significant indicators is the engine overheating, which may occur because the PCM cannot correctly regulate the engine's operating temperature. Additionally, drivers may experience poor fuel economy due to improper fuel mixture adjustments by the PCM based on erroneous temperature readings. Furthermore, the check engine light will likely illuminate on the dashboard, alerting the driver to the existence of this error. Addressing DTC P2184 promptly is important to prevent further engine damage and ensure vehicle reliability. These symptoms not only affect the vehicle's performance, but also the overall driving experience. The first troubleshooting step for DTC P2184 involves turning the vehicle to the on mode and checking the ECT Sensor 2 voltage using the Honda Diagnostic System, HDS. It is essential to ensure that the engine is off during this procedure. Only the ignition should be engaged. If the HDS displays an ECT Sensor 2 voltage reading of less than 0.08 V, this confirms the abnormality. This result indicates that there may be an issue with the ECT sensor itself, and further investigation is necessary to ascertain whether it is functioning correctly. If the voltage reading is above this threshold, the problem is likely related to another component in the circuit. prompting further testing of the wiring and the PCM. Documenting the voltage readings assists in corroborating the diagnosis. In the second troubleshooting step, you will need to disconnect the ECT Sensor 2 connector, which is typically a 2-pin connector, to begin further inspections. After disconnection, the next step is to perform continuity checks of the wiring harness associated with the ECT sensor. It is important to use an ohm meter to check for continuity and ensure there are no shorts or breaks in the wire. The HDS should again be used to verify that the ECT Sensor 2 voltage meets the specified conditions. And should you find any discrepancies, further inspections on the circuitry are warranted. This step is critical in ruling out wiring issues, which can frequently be the cause of DTC readings such as P2184. The third step in the troubleshooting process focuses on inspecting the TW2 sensor wiring for potential shorts. To do this, the PCM connector must first be disconnected. It's essential to complete this step by jumping the SCS line with the HDS and allowing the system to stabilize for more than 1 minute. After this, you should check if the TW2 sensor is shorted to ground. Using a multimeter, check for resistance if the readings are below 1 megaohm. This indicates an abnormal condition in the circuit. Documenting the findings is crucial, as persistent shorts may require further inspection of wire harness connections, and any faults discovered will need to be resolved to restore proper sensor function. Ensuring circuit integrity is vital for the overall operation of the ECT sensor. The fourth troubleshooting step involves inspecting the Powertrain Control Module (PCM) itself. If earlier steps indicated that both the ECT sensor and wiring are in good condition, the PCM is responsible for processing inputs from various sensors, including the ECT Sensor 2. If all other components have been checked and found to work properly, the issue may lie within the PCM circuitry, potentially requiring further diagnostics or replacement. This step is crucial, as a malfunctioning PCM can complicate any repairs and result in similar DTC codes. Should the investigation point to the PCM as the culprit, verifying its part number and ensuring compatibility before replacement is critical for restoring optimal vehicle function. Maintaining accurate records of all tests performed aids in troubleshooting efficiently. Final repair verification is an essential step after addressing DTC P2184 to ensure all issues have been resolved effectively. Begin by rechecking the functionality of the newly installed or repaired ECT sensor to confirm that it is operating within the normal voltage range. Utilize the HDS to monitor the ECT Sensor 2 voltage once more, ensuring it exceeds the 0.08 volts threshold. Additionally, a comprehensive circuit check should be conducted to rule out any potential connection errors that might have initiated the problem in the first place. If everything reads correctly, the overall functionality of the vehicle's engine management systems should be verified upon test driving the vehicle. This final assessment will indicate whether the repairs have successfully resolved the DTC and restored the system's integrity. Preventive maintenance is vital to minimize the occurrence of issues, like DTC P2184 in the future. Regularly scheduled inspections of the ECT sensor can preemptively identify any signs of wear or malfunction before they escalate into significant issues. It's advisable to include checks on the wiring harnesses for the ECT sensor during regular service intervals. Look for any signs of fraying or corrosion, especially around connectors, which could degrade the functioning of the sensor. Keeping the vehicle's cooling system in top shape will also help maintain consistent readings from the ECT sensor. By addressing these preventive measures, vehicle owners can ensure optimal system performance and longevity, aiding in efficient fuel consumption and reduced emissions. In conclusion, Troubleshooting DTC P2184 requires a structured approach to identify and rectify issues related to the Engine Coolant Temperature Sensor 2 circuit. It is imperative to initially verify the functionality of the ECT sensor itself, as this could be the primary cause of the error. Following that, it's crucial to ensure there are no wiring faults, which often lead to low voltage readings in the circuit. Lastly, should previous checks appear normal, the PCM's condition must be assessed to rule out any potential failures on its part. Adhering to preventive maintenance strategies, such as regular checks and assessments, can significantly reduce the likelihood of encountering this DTC again. Thorough understanding and proper response to DTC P2184 ensure optimal vehicle performance and reliability. Please like and subscribe to the channel. See you next time.